Okay, since it was midterm Friday, I guess I only need to go over one section today. So I guess after I'm done, I'll leave the rest of discussion for like, I don't know, if you have like homework questions or anything. Yeah. So let's get started. So let me just give the idea. So product rule for derivatives, right? I mean, this is like a beginner calculus person's dream that isn't true, right? Like when you derive, it's not this, right? Like you, I mean, that would be nice, right? Like instead of product rule, we have this. But sadly, we all know that it's plus g prime of x, f of x. So since integral is like antiderivative, and antiderivative is like the opposite of derivative, like you're going backwards. Well, if going forwards is not like this, then you should expect that this is not equal to integral f dx times integral g dx, right? Like, um, I mean, if it was, that would things would be really easy, right? We wouldn't need all these new techniques. We would just keep splitting it up. So basically, we need a product rule for integrals, and that's called integration by parts. So some books just denote IBP. Yeah, so we have integral f of x g prime of x dx is f of x g of x minus integral g of x f prime of x dx. So this is some people like the UV thing. So this is just dv uv v du if you like. Okay. So in English, like what are we doing? Like if you just ignore this, it's you integrate one, keep the other. So as you can see here, I integrated my g, right? My g prime became g. And I keep the other, so I kept the f. And then I subtract integral of integrated one. So the one you integrated, you keep. So integral of integrated one, which is the g, times, and then the one you kept, you derive, times derivative of other. Yeah. So that's if you view things in English, that is what's happening. But really what you're doing is, what are you doing? So instead of solving for this integral, you're solving this integral. Yeah. And so that should give you a clue on when to use integration by parts, right? Because what are you doing? The g prime became a g, the f became an f prime, right? So you would use by parts if the integral of one times derivative of the other is simpler to integrate. Yeah, let me put it that way. So, and just to convince you this is product rule, right? Integral fg prime, let me just rewrite it. Fg minus gf prime dx. So this is just product rule, because if you add, this is plus gf prime dx. And is this fg? Well, it is, because this thing is just fg prime. This is the product rule. And then FTC tells you this is fg, right? Sorry, FTC says the whole integral is fg plus constant c, but yeah. Okay. Is everyone clear on this? So we could do examples. So we're gonna start off easy. So let me just say, nobody's gonna tell you, what rule to use, right? So let me just start off with this because that's a common question. Like, no one's gonna tell you whether to do U sub, whether to do integration by parts, and whether to do something you'll learn in the future, like trig sub. So, but along with that, so assuming you choose to do integration by parts, nobody's gonna tell you which one's the U and which is the dv, right? Like, all I said was integrate one, keep the other, and then integrate the integrated one, derive the other, right? But which one you choose to do, that is entirely up to you. So, and sometimes, it's the wrong way. So let me just say the best way is, again, look at what you're doing, right? If you integrate it by parts, you're gonna get the integral of one times derivative of the other, right? So you want this thing to be simpler. Yeah. So here's my question. If is it simpler to integrate t, derive e to the 2t, or derive t and integrate e to the 2t? So let me walk this through with you the first time. So if I decided to integrate t and derive e to the 2t, right? E to the 2t if I derive it, it's going to be something times e to the 2t, like a constant times e to the 2t. If I integrate t, I end up with a t squared, right? Like a t squared. So I basically have something minus t squared e to the 2t. Now, here's the thing, like, is this simpler than this? Probably not, right? Like, if you didn't know how to integrate t times e to the 2t, the chances of you knowing how to integrate t squared times e to the 2t is is even worse, right? So do you see that, in this case, it makes sense to derive t, right? Because if I derive t, it's gone. Derivative t is 1. And then I'll just have integral of, like, say, e to the 2t. So let's do that. So let's derive this. So what I'm going to do is we're going to pick this as u, this is dv. Yeah. So if I integrate e to the 2t, it's 1/2 e to the 2t times t. So this is v, this is u. I'll write it out that way. And then derivative t is 1, this is du. And then I keep the v, right? And now you see this integral right here is much easier than this one. I'll put the t here now that you all see where it's going. 2t dt, and this you should know how to do, right? Minus 1/4. Sorry, I don't know why I did that. Plus c. Everyone clear on this example? Yes? No? Okay. So let's go over something similar. Just go over one more. So x sine of 10x. So same thing, right? If you chose to integrate x, I mean, derivative and integral of sine, I mean, you're going to get cosine of something. I mean, negative cosine of something, cosine of something, right? But if you integrate x, you're going to get like x squared times cosine of something when you integrate by parts. And that makes it even harder, right? Like if you didn't know how to integrate x times sine, chances are you don't know how to integrate x squared times cosine. So we always want to derive this and integrate this, yeah? So integral of this is, I think, negative 1 over 10 cosine of 10x times x. So if you like, this is v, this is u, minus integral. So derivative of x is 1, and then negative 10 cosine of 10x dx. So this is, again, b, this is du. So I get negative x over 10 cosine of 10x. So minus minus becomes plus, and I have 1 over 10 cosine of 10x dx. And this becomes easy now, right? This is just what? 1 over 100 sine of 10x plus c. Everyone follow so far? Good. It's pretty basic for now. Yeah, it'll get complicated in like the next, the next one of the, after these two, it'll get a little more complicated. So let's do something different than that actually looks different. So this thing, as of now, you have no choice. This thing is actually easier. Why? Because I mean, at least I didn't tell you, right? You don't know the antiderivative of natural log, right? So it's obvious that you want to derive natural log. In general, you always want to derive natural log. And like, even if you did know the antiderivative of natural log, it's not pretty. Yeah. It's not something very simple, like how derivative of natural log is just like 1 over t, right? So hopefully you know how to derive this, integrate this. So I get t to the 5th over 5, that's my v, times u, so it's just ln t. Derivative of ln, so this is u. Derivative ln t is 1 over t, so that's du, times t to the 5th over 5, so that's v. Yeah. And at this point, it's quite simple. Minus, what is that? 1/5 integral t to the 4th, right? And then you get t to the 5th over 25 plus c. Yeah. So yeah, here whenever normally if you're going to integrate by parts, you want and you see a natural log, you want to derive that. I would say like most of the time. Okay. Moving on. So let's do one more of the same thing. Yeah. So here, you need product, right? To use integration by parts, you need to write this as a product. So we could do it like this, right? And again, chances are you want to derive this, integrate this, right? So here I'm going to get what? Antiderivative of 1 over x squared is negative 1 over x, right? So again, this is b, this is u, minus integral 1 over x, which is du times negative 1 over x, which is v. So minus minus becomes plus, right? Integral 1 over x squared. So you should get this, right? Okay, I'm going a little fast on this because I mean, by now you should know power rule. Okay. Now, here's a thing on one of your web assigned homeworks. So I'm not gonna do that one. I mean, the technique's the same. I think it's like integral of cosine inverse. So to use integration by parts, you need two things, right? I mean, you need a u and dv, agree? Like you need to have two things being multiplied to each other. So what if I only give you one? I'm claiming to solve this, you need integration by parts. So which two functions am I using here? So to solve this, the technique for solving this, you would use on that cosine inverse question. I believe there was a cosine inverse question on the web assign, at least. So how can I write ln x as something times something? Hmm. Yeah, exactly. There's a hidden one, right? I can always write something as 1 times itself, right? And now we're golden because this is u, this is dv. So antiderivative of 1 is x, right? So this is vu minus 1 over x. That was ugly. Times x, right? So this is du and this is v. So x ln x minus integral of 1 dx, right? This is x ln x minus x plus this. So this is the antiderivative of natural log. As you can see, is not pretty. It's like, right? Because if you integrate by parts and you chose to integrate natural log, well, guess what? You're going to have a natural log term, right? if you didn't know how to integrate something with a natural log term, like here, right? If you do by parts and you integrate a natural log, you're still going to have a natural log term, right? So it's better to just get rid of natural log by deriving it. So on your web assign, you would have cosine inverse, right? So what you would do is you would rewrite that. It's the same technique. You would rewrite that as 1 times cosine inverse. You derive the cosine inverse. That you know, right? You know the derivative of inverse trig functions, and then you take the antiderivative of 1, which is x, and then that integral you should be able to solve. Yeah, I think you could solve it through like u sub or something. Everyone clear? So far? Okay. Okay, now let's do something harder. So let's think something through. Okay. So here's what I want you to think. We're going to do this by parts. The integral of e to the z and derivative of e to the z is the same, right? Because derivative of e to the z is e to the z. So when you integrate e to the z, it's still e to the z. So the question is, do we want an integral z to the fourth? Do we want to integrate z cubed? In which case I get something like z to the fourth times e to the z? Or do I want to derive and I get z squared, something like z squared e to the z? Which one should we go for? Let me see if you could get that correct first. Good. Now, that doesn't solve the question, right? It's still really hard to integrate z squared e to z. So what do I do then? So I changed integral z cubed e to the z to z squared e to the z. What do I do next? Good. I do it again. I derive that z squared. And now I have a z times e to the z. Now what do I do? We're almost there. One more step. So I now have something like z times e to the z. What do I do now? So if you just ignore this question and I gave you this instead, how would you solve it? Is what I'm asking. No. Yeah, it's the same exact thing. It's the same answer for all my questions. You just do it by parts again, right? If you do it by parts and you derive z, well, guess what? You're just gonna be left with something like integral e to the z. And this is easy, right? It's this. So that's the idea. So this question you can see just by looking, if you just think it through, it's integration by parts 3 times. Yeah, you keep reducing the power of z cubed. So let's do that. So let's derive this, integrate this. So if I integrate, nothing changes, right? Minus derive, if I derive this, I get c squared. I'll just write it out for the first part, yeah. I won't write it out for the rest, but this is v u du v, yeah. So let's write this out. Put the 3 outside. Yeah, easy. And now, right? Do by parts again, right? So integrate z squared e to the z minus integral 2z e to the z dz. That's what we do. So this is what we get when we integrate by parts. And now I get this. So if I FOIL the -3, I get this, right? Plus. So 3 times 2 is 6. So let's just write 6. And like we said earlier, right? Do antiderivative, do integration by parts of this. So this becomes 1. No, it becomes this minus integral e to the z dz. Yeah, and we are done pretty much. And you know how to integrate that last part. These are z's, by the way. The only 2 is right here. Minus 6 e to the z plus c. Everyone follow? Or get the concept? So the main point here is when you derive a polynomial, right? If you have a degree 5 polynomial, when you derive, it's degree 4, right? And when you derive again, it's degree 3. When you derive again, it's degree 2. When you derive again, it's 1. And when you derive again, it's 0. So you could kill off any polynomial by integrating by parts enough times. Yeah. Okay. So I think the WebAssign people really don't like students. So I'm just gonna do it without coefficients. Yeah. So I think in WebAssign, they really just make it pedantic for all of you by adding like a 2 and like maybe like a sine of 3x here. But like the that will just give you like algebra errors. Yeah. The main point is based off this. So once you understand this, you can do it with like 2s and 3s inside. It's just a lot. The numbers are not nice, right? You're gonna get like a 1/2 or like 1/9, something like that. Okay, so let's think this through. So what happens no matter what I choose? If I integrate e to the x, derive e to the x, I get e to the x. And no matter what I choose, if I integrate or derive sine, what do I get? Do you agree? I either get like cosine or negative cosine, depending on if I derive or integrate sine. Does everyone agree? Good. And if I don't know how to integrate e to the x sine x, chances are I don't know how to integrate e to the x cosine x, right? They're like pretty much of the same difficulty. So, but here's a saving grace. What happens if you derive sine twice or if you integrate sine twice? So pick either one. If I integrate sine twice, derive sine twice, what do I get? Not exactly sine again, but what? Negative sine. The negative is important, as I will show you later. I get negative of my original. The idea is when you do integration by part twice, the same way, right? Don't integrate one and then antiderivative the same one. So your u and v should be like the same choice. But if you do that, well, you're going to end up with the original integral, but maybe with a negative sign on it. Yeah. And then you can add it to both sides and sort of divide by 2 if you like. So that's the attack. So let me show you. So it doesn't matter which one you choose in this case, but since we like deriving, so let's just derive this. Yeah. So I'm gonna, this is e to the x sine x minus integral e to the x cosine x dx, right? Now let's integrate by parts again, right? This is same way. So I get e to the x cosine x minus the derivative of cosine x is negative sine x, right? So now I get this. So let me just write integral e to the x sine x dx is equal to. So this thing is e to the x sine x minus e to the x. So let me just say these two become plus, right? And if I distribute the minus sign in, I get a minus, right? Everyone agree? And hopefully you see what's next. So you should be careful here. Here's where the plus c comes in. So I'm claiming that this is actually 2 times. Obviously, if I add the same thing twice, it's just 2 times it normally, right? Like x plus x is 2x. Agree? If I add the same thing to itself, you just get 2 times it. But here it's 2 times it. Here is really the only tricky part. Plus c. So why is there a plus c? So the idea is let's do it something and something we do know. Yeah, like integral cosine x dx. If I add these two, if these are indefinite, this thing could be sine x plus c1. This thing could be sine x plus c2. Yeah, so when I add them, I get 2 sine x plus c1 plus c2. Yeah, so we just call this c. Yeah, so when you add 2 general antiderivatives, remember these are family of functions. So like you do end up with a constant. But let's subtract the c on both sides. So, and then divide by 2, and then that's your answer. But e to the x. And let's just say plus d, yeah, for a new constant. I mean, c runs through every constant, right? And so negative c over 2 still runs through every constant. And that's your answer. So same thing for your web assign, yeah? I think one of them had like e to the x times some trig function. It's the exact same, method. You integrate by parts twice, add that integral back to the other side, and divide by 2. Yeah. Or divide by whatever the coefficient is. So like I'm saying, like if there was like a 3 here and then like a 2 here, it could be a coefficient here, but the method of attack's the same. Exact same, actually. You just get nastier numbers. Everyone clear on this? Yes or no? Okay, so I'll end with a brain teaser. Yeah. So, but I think that previous question that should be enough to do your homework. Yeah. At least the integration by parts part. So let me quiz you a bit. So obviously, we all know this is natural log of absolute value of x, right? But suppose I'm a newbie. I I don't know that, but I know integration by parts. So I'm going to do the same process here. So I'm going to treat this as u, and this is dv. So if I integrate, I get x times 1 over x minus integral, right? So this is my v, this is u, right? And then derivative of 1 over x is negative 1 over x squared, right? This is du times v. This is v. So I get integral 1 over x dx is x times 1 over x is 1. Minus becomes plus. And then 1 over x squared times x is 1 over x. And then I do this. Zero equals 1. So my question is, what is wrong? I'll end it with this. So what do you think is wrong here? Pretty interesting question, huh? Well, I mean, obviously, 0 is not equal to 1, right? That's why I'm asking what is wrong. And yeah, obviously, 0 is not 1. So I'm asking, like, what did I do wrong? So think about what I said three minutes ago in that previous problem, the e to the sine x problem. Any idea? I mean, it's okay if to be wrong. I mean, like this isn't. I'm not like this isn't graded, so you could like say whatever you want. Hmm? I mean, I could, but I mean, I'm just. I mean, I could integrate twice, but I mean, like I just did integration by parts once, and I just subtracted on both sides. I got 0. So yeah, I mean, obviously we all know this is natural law. You don't need to integrate by parts here, but you could certainly do this. So let me ask this: is the integration by parts wrong, or is that correct? Let's look at the first line. Is that part correct, or is that valid? Like, did I make any algebra errors? I don't think I did. Okay. Well, this is obviously wrong. So obviously the incorrect part's right here. So what's incorrect about this? Here, think about what I did right here. Right here. Yeah, yeah, exactly. It's not 0. This thing should be like a c equals 1. Yeah. So this is a good example to remind you to always put the plus c. Yeah. So again, they could differ by a constant, right? One of them could be natural log absolute value of x plus 5. The other one could be natural log absolute value of x plus 3, right? So you need a c here. So there's no contradiction. Constant equals 1. That I mean, like, that's certainly fine. Yeah. Everyone good? Okay. So you have like 12 minutes. If you don't have any questions on homework and stuff, you could go. Um, I mean, yeah, but there's like I have like 12 minutes. You could ask me anything. But in terms of the topic, we are done for today.